Hello, my name is Fernando Munoz and I'm the General Manager of Scott G. Williams, L.L.C. We're located in Atlanta, Georgia, and we've been making agricultural and specialty chemicals since 1976. One of our most important product lines are granular chelates. Our chelates are derived from calcium, copper, iron, magnesium, manganese, and zinc. Our granular zinc chelates are used on crops such as tomatoes, corn, small grains, and pecan nuts. Our granular manganese chelates are used on palms, ferns, cotton, soybeans, and peanuts. And our granular iron chelates Fe13 and Fe5 are used on such diverse crops as tomatoes, citrus, and fine turf grasses. Today's discussion will focus on SGW's granular Fe13.
Dr. Sherman Ponder will now demonstrate the ferrous nature of the SGW granular Fe13 iron versus the traditional EDTA chelates. After measuring out 1 gram of a traditional chelate, he adds 100 grams of water in this beaker and turns the stirrer on. Please note that the traditional chelate makes a clear liquid and it's quite appropriate for use in some liquids. The SGW granular Fe13 demonstrates the buffering action of the ULTRACHELATOR technology, which makes our product better in soil application. Watch him add the water, turn on the spinner, and see that it takes a while for it to be completely dissolved. Now we will add NaOH into both beakers, a small amount into the traditional iron EDTA. Note the color change. As the traditional EDTA reacts with alkaline in the soil, or in this case in the liquid, it turns the ferric red-yellow. But the NaOH into the SGW granular Fe13 turns the traditional green color of the ferrous iron ion. The animation will indicate now how ferrous differentiates itself from ferric. On the left, the green ferrous iron goes right into the root hair. On the right, the yellow-red ferric iron must wait and be converted into ferrous by the root hair before it's taken up by the plant. We now switch from the beaker demonstration of ferrous to ferric to demonstrate how the ferrous is so important in the Fe13 product made by Scott G. Williams. The SGW granular Fe13 uses the ULTRACHELATOR technology to develop a chelator bus system. What happens is that the chelator bus goes to the Fe13 granule, loads itself with Fe+2 or the ferrous iron passengers, drives to the root hair, and empties the passengers of Fe+2 into the root hair. This animation will demonstrate the difference between ordinary iron in the soil versus SGW ultra-chelated iron. Ordinary iron will come into the soil in contact with phosphates, carbonates, clays, and other materials, which combine with it and knock out the iron, making it unavailable to the plant. However, the ultra-chelated iron comes in protected with the ultra-chelated system. We can see this also in the experiment with the two beakers. You'll recall that NaOH, or an alkaline solution, was put into each. Only a small amount was necessary to turn the traditional chelate into the ferric red color. Look at the extraordinary amount of NaOH that's put in to turn the Fe granular Fe13 into its green ferric color. A big difference between our product and the traditional chelates is the issue of dust. This is what happens when you take a powder or a dusty product and try to take it from one side to the other. Look at the difference with our pellets. These are actual Fe13 pellets.
Our granular Fe13 and granular Fe5 pellets can be shipped bulk in 1-ton mini bulk bags or in 50-pound or 22-kilo bags. Please note that we also offer all products in a polymer coated version that offers the customer a controlled release application. We're seeking customers and distributors around the world. Please contact us at Scott G. Williams, L.L.C., 2111 General Arts Road, Conyers, Georgia 30012. The plant phone number is 770-761-4448, and the manager's cell phone number is 404-323-2813. My email is sgwllc@aol.com. Scott G. Williams Granular FE13 and FE5. Insist on them by name.